the established delivery unit of Ericsson. These partnerships encompass a diverse team of approximately 40 professionals and the management of around 45 distinct delivery entities. Work in the development of IEEE platform for cloud native development and achieve Ericsson's scalability portfolio. He also has a distinct role of owner of the product development team. He plays a pivotal role in steering feature development and enhancements associated with the platform and its various he also has experience for Ericsson in the fields of managed service for IT, application development and maintenance, and transformers. As also
silence, please.
As an enterprise architect, where he has been instrumental in navigating complex investments and providing valuable architectural insights. So I think this session will be very interesting to you, and I hope that the different sessions which are you participating since yesterday will give you a lot of options to choose your careers. You will find a lot of opportunities that are coming up, as well as different skills which is required in the coming generation. I hope that we will enjoy this session.
And providing that opportunity. At times I feel a little kind of awkward to be here because, to be honest, in Bengali I can say that এটা বিবেকের দর্শন, কারণ আমরা যখন স্টুডেন্ট ছিলাম তখন যে খুব ভালো আদর্শ স্টুডেন্ট ছিলাম এরকম একদমই নয়। তো সেখানে দাঁড়িয়ে আজকে এখানে তোমাদের সামনে জ্ঞানের কথা বলবো অবশ্যই, কিন্তু সেটা বলতে গিয়ে একটু বিবেকের দর্শন হয়। But time is a big thing, so as time passes by, things changes. So you will also understand when you reach to that level. So because of that, I'm here today maybe, and what we will be discussing today, I want this to be more of a interactive session between you and us. So what we will be discussing is precisely this: the present, the future, and the opportunities that we have in the telecommunication industry. Because as you know, of course, that Ericsson is very much in this domain. I mean, they are one of the pioneers in this telecommunication industry, and because of that, we get involved into many of the development, many of the futuristic things that are happening in this industry. Right? So maybe I can share with you some of those initiatives and what exactly is happening around the world, not only in India but across the world, how the telecommunication industry is moving. And as we all know and understand that the telecommunication is not just another industry. Telecommunication in today's context is such an important thing that it is not only for the industry, not only for the business, but even for our day-to-day life. Everything that we do, right from my mobile phone to all modes of communication, everywhere telecommunication is the key, right? So it is absolutely important, not only from the professional perspective, but also very much from the social and personal perspectives as well, right? So we can't really ignore them. So if we look at this industry, what are the things that are happening today? I mean, as we speak, what are the things that are happening in this telecommunication industry? Now, this is important for us to understand because that's where the present is, and we all are very much in the present. Future is something, of course, that is important because that will come in future. But to understand the future, or even to be prepared for the future, we need to understand the present first, right? Because that is the best. Now, I'm sure the topics or the keywords per se that we will be discussing, I think we all are very much familiar with that. those keywords at least. But what is important is to go at least one step deeper into those keywords. What that particular keyword exactly means. Right now, 5G as a keyword, as a terminology, I'm pretty much sure that all of you are very much aware of that, right? Anybody who doesn't know 5G? I don't think there is anybody, right? Every one of us know that there is something called 5G which is coming up, which has a lot of potential, lot of probably hopes around that, right? Both in the industry as well as within our day-to-day life as well. But we'll see what exactly is this. Then another terminology is IoT, Internet of Things, right? So Internet of Things is also another concept, another terminology which I am pretty much sure that many of us are aware, if not all. So that is another thing. We will get into the details of each of them, but that is another area which is kind of becoming more and more relevant for us. Artificial intelligence and machine learning, just now we had a session on that, so by now you understood the importance and the prospect of this artificial intelligence and machine learning. I'm not going into the details of it. Then the hybrid cloud. Now I'm not sure whether all of you are very much familiar with that, but we will again discuss a little bit more on that. But what I can say that this hybrid cloud concept is the destination for all our IT initiatives going forward. That is what is going to be there, nothing else, no other mode of computing. So hybrid cloud is the destination for us as far as our IT assets are concerned. So we'll see what exactly it is. So cyber security. As we are moving towards these technologies, this cloud enablement and all other stuff, this cyber security is of immense importance, which eventually we'll cover as part of the next session. So we will see in detail, just like the AI and machine learning, what exactly we have as part of cyber security. And then last but not the least, I'm sure this terminology you have heard, but what exactly does that mean that is important for us to know? And that is digital transformation, which is kind of putting all these things together. Now this digital transformation is there today, and this is going to stay as well for the future. Because this is not something that you can complete in a year or two, or maybe in a short span of time. So this is necessarily a journey that we need to all get into and embrace that as well. So we'll see what does exactly that digital transformation is. Now, if I get into the specifics of each one of them, now, first point, the 5G initiatives. So just to give you the context, I guess many of you are aware that Ericsson as a company is involved in defining the specification and the structure of this 5G concept, right? So that way we have a kind of not only understanding but a strong contribution towards the 5G specification. Now if we look at those specifications, what it is? Of course, it is, to start with, it is about the speed. The speed of the network that we eventually get. Now, how that is achieved? Because as part of 5G, we are using a much shorter wavelength. Now, if you compare to from 1G till, there was something called 1GSS, but from 2G, 3G, 4G, and then 5G, you see the wavelength for the transmission wave is getting shorter and shorter. So the more shorter you have the wavelength, you can pack more information into it, and you can basically achieve a higher amount of bandwidth, more amount of data you can transmit through those signals. Now, if you look at it from a traditional standpoint, 4G allows up to 1 Gbps kind of speed, but in 5G we are saying it will be in and around 20 Gbps. To be even more than that, in and around that 20 Gbps is the mark for the 5G spectrum. Now, as of now, in many countries, the 5G rollout is happening. So as we speak, the commercial 5G rollout is happening across the world. So this map, as you can see, is basically indicating where all it is kind of already commercially launched, and then where all it is in progress, and where there are some investments being made towards that. Now, in the most of the Western world and advanced countries, you have the 5G network already rolled out. Now, for all of these 5G rollouts, it is necessarily the lower end of the spectrum that is being used. So there also we are getting significant improvement in terms of speed. But if we move, or once we move into the higher spectrum of the 5G band, then we will have much more capabilities which are possible as part of that. And what are those? For example, the next one, the ultra low latency, which is less than 5 milliseconds, against typically which is about 60 to 98 in traditional 4G network. So this ultra low latency is actually the time that it takes for any device to get connected to the network. Right? Now this is extremely important, not for making a phone call or watching a video. This is important when you are using that connectivity for a mission critical application. So what are those mission critical applications? For example, you are running a driverless car. So if your connectivity lags, then you can assume, you can anticipate what can go wrong and what can happen. So that is absolutely not allowed. So you are running industrial process, maybe you are controlling a blast furnace or an atomic reactor or things like that, right? So there the latency is extremely important because you cannot afford to have any delay in the connectivity process. So there it is absolutely important. So one thing we must understand that this need for 5G is not so much for making phone calls or watching videos or consuming data, right? So the biggest need for 5G is coming from the industry, where we are trying to automate them. We are trying to provide a connectivity platform for the industries and the use cases like this, driverless car or remote operation, where doctors are sitting somewhere else, the operation is done completely through a robotic process with a very high-end connectivity. So those are the scenarios where 5G is most relevant. I will come back to that point, but before that, very quickly, some other features like the virtualization and software-driven nature, this 5G network, and that's where these two industries are getting converged. So there is hardly any physical equipment in today's 5G networks, right? It's all IP networks, so whatever network components you have is nothing but software components. And they are running in very standard hardwares. The hardwares where we are running all our other software programs. So just like your Python code or any other Java code or C++ code, your network nodes are also running just like a software component. So this is all about all IP and all software network. Right? And then there are certain techniques or certain technologies which are being utilized as part of this overall 5G concept, which makes this faster, which makes this low latency possible. Right? What are those? Not all of them, because that's a long story. Maybe some of them, which is important for us to know at least at a conceptual level, may not be at the depth of it, but at a conceptual level, first of all, there is a concept of small cells. You can understand from your, practical experience that if we have a shorter bandwidth wavelength, shorter wavelength microwave signal, so that cannot travel very far. So in traditional 4G or 3G kind of scenarios, you have big towers, which is kind of covering a 5-kilometer area. So you can receive signals all across that area. In 5G, that is not possible because you are using a much shorter wavelength. So there we need to have small cells. So there will be many antennas spread across maybe a street or a region, which will cover maybe 1 kilometer, 500 meters, that kind of area. And there has to be proper handshake between these areas. So that's a challenge. challenge in terms of putting that 5G infrastructure in place, and that's why the kind of rollout pace is little slower than we expected, because it requires a lot of small cells which needs to be interconnected.
Sorry, by shorter than what is the spectrum you're mentioning?
So it is the 5G spectrum band that we have, which is, I don't remember the exact numbers, but it's a huge range. So right now, whatever commercial trials are going on, it is the initial part of the 5G spectrum bandwidth. And that itself is capable of about 20 Gbps of data as part of those signals. Now once we move up in that higher spectrum band, then it will be capable of handling much more data. And then there is another concept as part of this 5G, and that is extremely important, which is MIMO and beamforming. Now, this MIMO is basically multiple input and multiple output, which is part of the antenna architecture. And this beamforming is also kind of similar area, which directs the kind of the microwave in a particular direction from where the request is coming. So these two technologies together is actually getting applied in the 5G antennas that are being positioned across the small cells, right? So these two together makes it possible to have a 5G signal getting up to your handset. And then this another two concepts, carrier aggregation and this D2D communication, is basically to facilitate more information being communicated as part of those signals. Now, in carrier aggregation, basically we are combining or collating multiple carrier signals into one signal itself. So it's basically zipping the signals into one particular wavelength. And then D2D communication is the device, 5G capable device, they can communicate directly to each other once they are in close proximity. So that it kind of reduces the dependency on the underlying 5G network. So taking all of these together, conceptually, this actually constructs the 5G network for us. Now, if I move on, then the next topic which we discussed is basically the IoT, which is Internet of Things. Now, what it is? Conceptually, I guess all of us kind of understand this, that even in today's world as well, you see a lot of smart devices. Now, by smart device, what do we mean? The devices, first of all, which are connected to internet or connected to a communication system, and they intelligently transmit certain data elements which either you can collect and interpret to assess its state, or even you can, through those communication channels, you can instruct the device remotely to do certain things. Right? So we are aware about smart cars, of course, because now the advanced cars, most of the cars, you can do a lot of things remotely. Even you can check the vehicle position and you can start the engine, you can park the car and do many more things. Other than those various consumer electronic devices also, like the AC, the fridge, etc., they come with smart features nowadays. So this is gradually becoming a reality. So the vision is that maybe going forward, and especially when we have the 5G network in place, because these two are kind of related. And why it is related? Because the moment you will have lot of smart devices like the one we are discussing, the IoT-enabled devices, they will communicate a lot of data. They will emit a lot of data. And the underlying network through which they are communicating with each other, they need to be able to consume that data and process that data so that it will be usable at the end of the day. So these two things, 5G network and IoT devices, are kind of linked very, very closely. So what happens in a typical IoT implementation scenario? So if you look at this diagram, we have the IoT devices, or we call them sensors, from IoT standpoint, because the sensors are the actual circuits which is responsible for that communication and transmitting the information, required information to the rest of the communication system. So these sensors are then embedded into the actual device. Now these sensors typically are connected to a gateway, which is kind of local to your or near to your device. So all these individual devices necessarily doesn't communicate to the back-end server which you have maybe in a central location. So instead of that, because if that happens, then there is huge amount of traffic that you need to flow to that main server. So instead of doing that, what typically is done is you have a local gateway through which these devices are connected, and then that local gateway in turn can connect to the cloud gateway, which is your one centralized entity. So there you get a lot of data from these individual devices or individual sensors. Then at that layer, we do some sort of data processing, right? So after processing that raw data which is coming from those sensors, we are putting them in a data lake, which is also a central repository, but there we are storing only the meaningful or the processed data, not everything. And then on top of which we have a big data platform where those data is being structured, analyzed, all the algorithms are applied. You have all sorts of AIML algorithms, you may have all those running on top of that data, and then from there you are deriving meaningful information. And then on the other hand, you have a channel through which you can push your commands or instruction to the same route to the individual sensors or the individual device. So that's how this entire kind of IoT ecosystem works. So you can use this ecosystem, this IoT-enabled devices, not only for the consumer electronics or cars. You can very well use them in the industry as well, and that's how most of the uses are. For example, equipment monitoring. You have multiple equipments in a factory, so you need to monitor them remotely, so all that is possible, and that is in today's world very much happens through this IoT technologies. Hazard detection, industrial monitoring, autonomous cars. Then we have the concept of smart cities, right? So in our locality, the new town itself is a smart city, which is one of the, 12 or 16 smart cities declared in India, right? So for implementation of those smart cities, there is a huge amount of usage of the IoT technologies. For example, of the street lights, they will automatically go on and go off depending upon the daylight. So these are some of the usage of the IoT technologies in today's world. AIML, I will not get into the details of it because already you have heard a lot about it. If I just want to categorize them, you can categorize them broadly into these three parts. One is natural language processing algorithms. There are many, and there are many use cases of natural language processing. Then there is a set of algorithms for anomaly detection, which is basically nothing but pattern matching. You have huge amount of data, you need to find out the outliers. Now, if it is a clear outlier, then through the standard statistical methodology, you can very well do that. But if the outliers are close to the mainstream of data, then it is difficult through the standard statistical model. Then you need to apply the AIML models on top of that. So that is another category. And then, of course, the last but not the least, very, very promising, there is a generative AI, where you are doing all sorts of this using this distribution model, the vectorial anecdotes and the generation of the content. So all of that is applicable not only to the text but also to the image, voice, all kinds of artifacts we can generate from the generative AI. And the usage of AIML, I think we all understand, we heard that as well. Now the next point, which is the hybrid cloud. And this is extremely important, especially from the IT standpoint. Now, by hybrid cloud, what we mean in the first place? Because this is not so much a common term, although it is maybe known to many of you. So there are multiple type of cloud implementation. I think the concept of cloud is clear to everybody, I am assuming, is that instead of before cloud, what we used to have? We used to have the on-premise data centers. So the big organization or maybe third parties, they used to have their own data centers where they used to host the servers, where all our IT programs, IT assets used to run. So that was the traditional engagement. Now after that, we are coming into the age of cloud computing, where there are various types of cloud providers. It is not only the public cloud, which we are probably more familiar with, for example, Amazon, Google, the Microsoft Azure. So these are some of the public cloud providers. But other than public cloud providers, we have the mechanism of setting up private clouds as well. So on top of your on-premise data centers, they are also, instead of having the physical servers, you can club all those physical servers and create your private cloud environment. So the only difference is, in a physical server, let's say this laptop is a physical server in itself. It's a physical machine. So whatever resource this laptop has in terms of CPU, memory, hard disk, storage capabilities, that belongs to that machine. So if I have another laptop which is lying over there, that also has similar resources, right? That also has CPU, memory, disk, everything. But this laptop or some program running in this laptop cannot utilize that resource. These are specific to the machines. When we are talking about cloud, there necessarily what is happening, that these resources, these compute resources, be it memory, be it CPU, be it storage, these things are getting shared across the physical machines. Still you have the physical machines, but now they are connected in such a way that any program running in that environment can utilize that common pool. So you have a common pool, if you have 4 machines, then across those 4 machines, whatever is the total compute capacity, that is the capacity for the cloud. And your program can intelligently use that particular resource. That is the fundamental difference between a traditional computing and a cloud computing. Now, these are the variants or types of cloud computing. For example, private cloud, that means we are setting the cloud in the on-premise data center, utilizing my own hardware. Then comes the public cloud, which is provided by these sort of, ACPs, hyperscaler players. They are providing us a infrastructure. We don't know where they are hosted, how they are hosted. In fact, they are scattered all over the world. So they are providing us a aggregate compute capacity. So from there you can subscribe whatever you need. Right? So that is the public cloud. Then comes the multi-cloud. That means if you have multiple such things, you have multiple private cloud or multiple public cloud. So let's say you have taken some resources from AWS, you have taken some resources from Google, and then you are combining them together. So that is essentially multi-cloud. And then hybrid cloud is that some part of your resources or some part of your program is running on a private cloud and some part of it is running on a public cloud. So you have a combination of both private and public cloud in a single scenario. So that is what is called the hybrid cloud, and that is probably the most efficient or most suitable way of doing the computation in today's world. Because, you will understand one thing, that in many countries, including India, we have some restrictions in terms of where we can store our data. Right? We cannot store data anywhere and everywhere. Even, for example, European Union, all the European Union countries, they have a restriction that they have to host their customers' data, etc. within the European Union. They cannot, they will not allow somebody to take it out. Similarly, US has some restriction, Middle East has very strict restrictions. So most of the countries have some sort of restriction on the usage of data. So maybe in your IT system design, you can think that you will keep the data in your private cloud, and the programs which will use that data, that will reside on the public cloud. Right? So that kind of segregation is very much necessary, and that is what is happening. That's where the industry is moving. Right? So that's why I said that this hybrid cloud, which is a combination of both public and private, it is the destination for all our IT assets. Now, with this concept, with this cloud computing concept, there is one more concept which is absolutely necessary for us to understand, and which is also kind of gaining momentum, and that is edge computing. So I think you are at least heard that term, edge computing. So what that is necessarily, so in the last, the previous slide, I think you have seen that IoT deployment scenario. So there you see there are some components which are lying close to the devices, close to the sensors, and there we are processing some amount of data, we are doing some business logic processing over there. So that is necessarily the essence of edge computing, where we are saying that not the bulk of the processing, but some part of the processing which need to happen upfront. Those processing we will be doing near to the source of the information. We will not take all the data back to the server, central server, and do everything over there, because in that case we need huge amount of capacity, huge amount of resource as part of those deployments, and it will be time consuming and costly as well. Right? So that's why we will use some amount of processing near to the source of the information, and that is precisely what this edge computing is all about. And so here also there are different kinds of edge computing. For example, it is device centric, and we have something called device edge computing, sensor edge, we have on-premise edge, which is the other capabilities you want on top of that infrastructure. So that is called infrastructure as a service. They are providing the wares and the application stack along with the infrastructure. So that is basically platform as a service. And then on top of that platform, they are putting the specific softwares that you need. That you need a customer relationship management solution, you need a billing solution, whatever. So they are providing that particular solution on top of that. Then that is software as a service. So of course, software as a service is the costliest, then platform as a service, and the infrastructure as a service is the least. So from a public cloud adoption standpoint, of course, infrastructure as a service is the most popular one, because that's where people see the biggest advantage. But it is possible to have platform as a service and software as a service as well. Right? So I guess this is clear. Cybersecurity, again, I will not get into the details, because in the next session we will have in detailed discussion. But one thing is very important for us to understand, and that is in this cloud native world. I will come back to cloud native after some time, but in this cloud world where we are hosting some part of my application in one data center which is local, many other parts are distributed all over the globe in multiple data centers. We don't even know where they are, how they are organized. So in such a scenario, the security is of utmost importance. So cyber security, because we are exposing our vulnerabilities all across, in terms of communication, in terms of compute, in terms of the softwares that are running, authentication, verification, everything. So that's why cyber security is of utmost importance in this cloud native computing, and then that needs to be handled in a very, very structured way. Now, in that list, this is the last point, and this last point is necessarily something which is collating everything together. Whatever concepts we have discussed so far, it is basically a conglomeration of all of these. So first of all, if I break it down, what are these? First of all, hybrid cloud infrastructure, which we discussed. So as part of digital transformation, the aim is to achieve all of these things. And that if we can achieve them, we can say that we have done the cloud transformation completely. It is difficult, it's, not a very straightforward thing or quick thing to achieve. So it's a journey basically that eventually the businesses will achieve. Many of the enterprise, they are already very mature state, but most of the other industries, I would say, they are still catching up in this journey. But what needs to be done is precisely this. First of all, hybrid cloud infrastructure, we need to move our IT assets into that. Then we need to embrace cloud native computing. And I think this is the most important keyword in the context of this digital transformation. Now, what is this? What is this cloud native computing? If I kind of simplify this, rather oversimplify this, then this constitutes these four things. One is the architecture of the solution that you will be designing the IT solution that will be microservice based. That means instead of having a big application which does so many things, instead of doing that, you will design your system such a way that you have small functions which is responsible for a particular task. That's how the modern IT systems are designed. It is not like previously we used to have a long code, which is running pages after pages and doing many things in one code. That is not how the software is designed to. It is a small piece of code which is responsible for doing a particular task. And then you are deploying that small piece of code as an independent entity. Right? And that independent entity is called containerized deployment. So your particular business function for which you have written the code, that is independently deployed as a container. Right? So this concept of container is another fundamental concept or principle of this cloud native computing. So whatever softwares you are developing, you are not developing them as a large chunk of jar file or an application server, you are deploying them. You are deploying them as a small entity called a container. Right? Then there will be lots of such containers because now you are breaking your entire software into small pieces and deploying them as small containers. These containers, you can assume that they are having one virtual machines or one computers, let's say, which is independent of each other. Now, if you have thousands of them, how you will manage them? Now you find it difficult to manage even one computer, right? So if you have hundreds and thousands of them, you need to manage their life cycle automatically, right? So that is the third fundamental principle of cloud native. So the life cycle will be managed through something, typically in today's context which is most popular. There are other ways also. In today's context, this life cycle of containers are managed through Kubernetes. I think some of you might have heard that now. So Kubernetes is the way of managing this container life cycle. So that is the third piece. And then last, the fourth one, but very important, in terms of the development life cycle, how you are developing these software assets. So there, how you are not only developing, but you are deploying. How you are developing as well as deploying and testing. So development, deployment, testing. These three things, automation of these three things is called DevOps, or in today's context, DevSecOps, because you are also securing them. So that is the fourth pillar. Right? So these four things together is basically constituting our cloud native infrastructure. Right? And then there are so many other things briefly which we have discussed, like cloud native network functions in terms of the communication service, artificial intelligence, machine learning, we have discussed big data analytics, the data lake we discussed, Internet of Things we discussed, edge computing we discussed, and cyber security we will discuss. So all these things together, once we achieve them, we can say that this is a transformed digital landscape. Any question from? interest of time, I will move on to very quickly the futures. I will not get into the details of the future because that is practically not possible. Very briefly, what is the future? So 6G, I'm not sure whether you have heard about 6G, but 6G is something which is coming up for sure. Researches are going on. We are involved deeply into that, and the target is about 2030, by when the 6G specifications will be out and we will see 6G in action. So I will not get into the details because this is extremely confidential information, but one thing I can, as an example, I can give you. So here, if you combine whatever we have discussed or whatever we have heard about this AIML, if you combine them with the 5G network, then whatever comes out is basically 6G. So from your experience, you can understand that when we have an event, let's say you are having a football match or you are having a some sort of gathering in a particular location, suddenly the need for the network usage increases, right? But when you deploy your network, it's kind of you deploy them uniformly, and then there is a concept of network slicing, to which you allocate bandwidth to some segment of the particular network, but that needs to be done manually. Now in 6G, what we are trying to achieve, and by the way, we, as Ericsson is very much involved into that, those things are happening here in Kolkata as well to some extent, but what we are trying to achieve is to put artificial intelligence into the network itself so that it can decide on its own that where to allocate bandwidth and how much. And so that is all about 6G. Then,
point out some of the information regarding the job openings and the criteria requirements as a student if they want to
absolutely. So that was basically the next slide. I mean, very next slide is precisely on that. So I will very quickly cover this. So very briefly, Starlink is the initiative where I'm not sure whether you are aware that Elon Musk is trying to have a satellite-based telecommunication network. So that is nothing but the Starlink. So it has a potential of replacing the way that we are communicating today. And very much in that context of that communication, this ORAN, which is the future of that. This SAN, the social network analysis, is the future of the AIML and the social network that we have today. iWays is the future of IoT, which is the Internet of Senses, where you are including all our other feelings or sensory organs input into that. And then, last but not the least, the nanocore, which is a combination of nanotechnology and quantum computing. This is, in my view, is the future of the IT industry, but not immediately. Again, it is still in a kind of nascent state and is evolving. Now, coming back to the last slide, which I think we are kind of eager to know. If you, in the context of whatever we have discussed so far, if you look at the telecommunications job market, what people are looking for, what the companies are looking for, right, is precisely this, and this is the latest data as well. So the span that has been considered here is from 2018 to 2025. So we are in the middle of it. So as you can see, this cloud computing as a skill or as a competence area is leading this with a 17% kind of growth year on year, right? After that, big data analytics, Internet of Things, encryption and cybersecurity, then AIML, NLP. So very much the things that we discussed just now and in the course of the day, you see those are the things which are very much at the top, right? So in terms of, and this is mostly, this data is mostly based on the, the Indian IT companies' requirements. right? But this very well, kind of represents the global requirements as well. Now, if this is the requirement from the industry basically, the kind of some feedbacks from the industry is also interesting. That means, if you look at them, 63% of the recruiters are saying that they are not getting the right kind of talent or they are having a shortage of talent in these areas. That means, that clearly indicates that there is not enough talent available in these areas. That does not mean that we don't have people in the market. Of course, there are people. But there is a mismatch between the people and the competency required. Right? So that is ideally, in my view, that is the gap that we need to bridge collectively. Right? And all other parameters, if you see, they kind of indicate that they're looking for something, but whatever they're looking for is not available in the market. So in general, maybe the prospect or the outlook for the IT industry, it might seem that it's not that great in coming years, right? But that is a partial truth. It is true for some of the traditional segments, but for the niche areas, whatever we discussed. So for the niche areas, I think the demand is even greater than what we used to have earlier, because that is the direction the entire IT industry and telecommunication industry is moving, right? So now if I come out of the presentation and share my personal experience on that, because we are dealing with that on a day-to-day basis. So my observation or my recommendation will be that, of course, you need to be aware about these terminologies, especially the top ones, whatever we discussed, right? For example, the cloud computing concepts, the big data analytics, AIML, cybersecurity, these are definitely the key topics that we need to know. But, and this is where the challenge is, but how you will contribute, especially when you are joining industry as a fresher, right? So it is not expected at all from any of you. Nobody will expect that you will be a master in AIML or you will be a master in cloud computing. That is practically not possible. So you are aware that things exist like that and you are fundamentally aware about the basics of it. But what you need to be expert, in my view, is, of course, as it was discussed, on the fundamentals of the mathematics, etc. But beyond that, in terms of computer knowledge, you need to have the programming skill. And believe me, if you have programming skill in any one language, that is good enough. Because if you know Java, if you know C++, then you can learn any other programming language in maybe few months' time, if not weeks. Right? So if you know Java, you are good at Java, you can learn Python. If you are good in Python, you can learn other languages as well. Right? If you are good in C++, then you can learn anything in the world. Right? So that is why it is not only about language, but with the language comes the programming skill, the problem solving skill. And that is the key. So if you know one language and if you have the problem solving skill, and third point is you know these terminologies, these topics, because in the interviews these questions will be asked. Whatever is asked in interviews is not necessarily what you will be working, that we all know, right? So in the interviews these questions will be asked for sure, just to see whether you are aware or not. But when you will start working on the ground, on the projects, then what is required is your programming skill, analytics skill, and knowledge on at least one programming language. That is the fundamental. Now, along with that, one more thing you need to know, and that is basically the ways of working today, and that is the concept of DevOps. Because it is not the traditional way that somebody else will be packaging the software and deploying it for you. Whatever you are developing as a developer, you are responsible for the lifecycle management of that. You only need to make them as container deployed. So you will not do that just by writing commands. You will do that using a tool or a system. And that tool or the system is basically your DevOps infrastructure. So you need to know, the fourth thing that you need to know is the DevOps. Right? At least one DevOps tool and the concepts. So that's all, nothing else. The concepts of these, one programming language, concept of programming, and one tool and concept of DevOps. So that's all from my side. That's your part of the information you are keeping in your private cloud, because that is more secure. And you have complete control. You have complete control over the physical infrastructure as well. Right? And then that not so kind of sensitive information or the applications themselves you can run on the public cloud. And that's how most of the softwares are run.
So hybrid will be the
Hybrid will be there. As we discussed, is kind of is very much there now in various contexts. Probably the most prevalent context is in the context of IoT devices, because there actually you need to process huge amount of data, and not all the data is actually meaningful or relevant. It may not be stored. So only the effective ones or the anomaly record that needs to be stored. So that's why in the context of IoT, we are using the edge computing very frequently. But not only that, for example, let's say Facebook or WhatsApp that you are using, they are not taking all the bits, all the inputs to the backend server. So they have country-specific age, region-specific age. In Kolkata they have age. So they are processing all the requests from this region. So, right, so that's basically the challenge that all these 5G operators are kind of struggling to solve. But for these small cells, there are multiple techniques. For example, there are typically the kind of routers that we have in our homes as well. Some advanced version of that which can cater maybe few 100 meters and all. So those kind of routers are put in the streets or the buildings which can cover a particular area. And because there is no concept of large towers in the context of 5G, or especially when we are moving higher in the bandwidth. So that's why, as of now, the 5G rollouts are mostly centered around the business district areas where you have a lot of office space, and then you have very close community, a lot of people are staying, or the events. For example, a match is happening or a particular event is happening in a particular location. So they are putting those antennas and those routers which are making that zone a 5G compliant zone. Because mass scale rollout, especially in the rural areas and all, is still not happening, and probably that's the reason, or the alternative to that is the Starlink project which Elon Musk is launching, which is providing the connectivity through the satellites.
They have required already, but unfortunately the company has reported that they are going to be bandwidth which has been already created by means of this company. But the proportionate amount of applications has not been generated to utilize those bandwidth.
Exactly, because see, this is another interesting point, and that's why I would say in a global scenario, the 5G rollout is not taking pace. Because who will use 5G? It's not us, not the consumers like us. Because it's not used for making a phone call or watching videos. This is to be used by the industry. Now, because of the geopolitical scenario, the wars, these, that, the appetite in the industry is very, very less. So nobody is making additional investments, nobody is venturing into new territories. For example, the consumer electronics industry. We expect that that is going to be the biggest consumer of 5G. Now you have smart cars or smart TV fridge coming with the embedded SIM, and which is using this network to communicate their data. But that phase or that rollout is extremely slow because there is not much of appetite from the consumers also and from the business side also. That is very true. In fact, that is the same scenario is there in US as well.